Welcome to the DIY Honda Garage channel. The DTC code P0135 indicates a malfunction in the heater circuit of the air-fuel ratio, AF, sensor 1 in the Honda CR-V model year 2023 and later. The AF sensor plays a crucial role in measuring the amount of air and fuel entering the engine, which is essential for optimal engine performance and emissions control. Located upstream of the catalytic converter, this sensor sends signals to the powertrain control module, PCM, regarding the air-fuel mixture. The PCM uses these signals to adjust fuel delivery, ensuring a proper combustion process. When the circuit malfunctions, the sensor may send unregulated signals to the PCM, prompting the storage of this DTC. Additionally, it's important to cross-reference this diagnostic trouble code with related codes, particularly those concerning the PGM-FI subrelay, like P1658 and P1659, to ensure a comprehensive diagnostic approach. The AF sensor, essential for calculating the correct air-fuel mixture, is critical for engine efficiency and emissions control. It regulates the air-fuel ratio by measuring the concentration of oxygen in the exhaust gases. If the sensor detects a rich or lean mixture, it sends signals to the PCM, which makes necessary adjustments to maintain optimal engine function. The AF sensor is typically found in the exhaust manifold area just before the catalytic converter, making it sensitive to temperature changes and exhaust gases. The PCM is responsible for interpreting the AF sensor's readings and adjusting fuel delivery accordingly. So any fault in the sensor's heater circuit can lead to erroneous programming by the PCM, resulting in poor engine performance or increased emissions. Several factors can contribute to DTC P0135, primarily focusing on the heater circuit of the AF sensor. A malfunction in this circuit may indicate a broken or damaged wire or a faulty connection that disrupts the sensor's operation. Beyond wiring issues, the AF sensor itself could be defective, possibly due to age or exposure to extreme conditions within the exhaust system. It's crucial to investigate these potential causes during the diagnosis process, as resolving wiring issues can sometimes be straightforward, while sensor replacement may involve additional labor and cost. Using the Honda diagnostic system can help pinpoint whether the issue lies within the sensor, its connections, or the PCM. When DTC P0135 is triggered, you may experience various symptoms that indicate a problem with the AF sensor. Engine performance can be notably affected, leading to hesitations during acceleration or a rough idle, which is primarily caused by incorrect fuel delivery as the PCM struggles with inaccurate sensor data. Increased emissions may also occur as the engine may run too rich or too lean, leading to potential failure in emission tests. Additionally, drivers may notice a significant decline in fuel economy as the vehicle attempts to compensate for the faulty sensor readings. Addressing this DTC promptly is beneficial not only for vehicle efficiency, but also to prevent larger issues down the line. The first troubleshooting procedure for DTC P0135 involves starting the vehicle's engine and stabilizing the engine speed at 3,000 revolutions per minute, RPM, without any load. This will warm up the exhaust gases and, in turn, the A-factor sensor, allowing it to function properly during the test. Continue to maintain this RPM until the radiator fan activates, indicating that the engine has reached its operating temperature. After this, allow the engine to return to idle. This confirmation procedure tests the system's performance under controlled conditions, which is essential for identifying the presence of any faults. Documenting the readings during this procedure is crucial for further diagnostics, as it provides a baseline for sensor performance. In the second step of troubleshooting, you will disconnect the AF sensor, Sensor 1 connector, specifically the 6-pin connector. With the connector removed, start inspecting the sensor to assess its condition and internal circuitry. This involves measuring the resistance across the sensor's terminals with a multimeter. Under normal conditions, the resistance should range between 2.8 to 4.5 ohms at room temperature. A reading outside this specification suggests that the sensor is either faulty or damaged, indicating that it may require replacement. Remember that if the sensor is installed during this inspection, it should also not show short circuits. Proper documentation of these readings will guide further action and repair options. Next, the focus shifts to the IGPS LAF circuit, which requires you to keep the A4 sensor, Sensor 1, connector disconnected. With the ignition switch in the on position, check for the presence of 12-volt battery voltage at this circuit. This voltage is essential for the proper functioning of the A4 sensor's heater element. An absence of voltage or a reading that does not align with the expected output indicates a circuit malfunction, which may involve damaged wiring or issues related to the ignition power supply. Proper analysis of this circuit ensures that the power supply to the sensor is intact, thereby ruling out power-related faults before considering sensor replacement. The fourth step involves inspecting the AFHTN circuit for faults. Prior to this inspection, make sure to disconnect both the AF sensor, Sensor 1, and PCM connector. With both connectors disengaged, test for open wires within this circuit to ensure continuity. A reading of less than 1 ohm indicates that the circuit is functioning correctly. If an open wire is detected, this can lead to improper signals sent back to the PCM. Additionally, you must assess whether the AFHTN circuit might be shorted to ground. A measurement of greater than 1 megaohm suggests no grounding issues. This step is crucial as it helps isolate potential wiring defects that can lead to the DTC being stored. Finally, if all previous inspection results indicate normal conditions, the next step is to assess the Powertrain Control Module, PCM. The PCM interprets the data from various sensors and controls engine functions accordingly. It is possible that upon ruling out other components, the PCM may itself be faulty. The diagnosis should include checking its internal processes and ensuring they align with other operational components in the system. Cross-referencing with other diagnostic trouble codes related to the PGM-FI subrelay and their symptoms can also be beneficial, as this may reveal interrelated issues. Ultimately, this step helps ensure that any electronic control unit faults are adequately identified before concluding the diagnostics. After completing the troubleshooting steps and making necessary repairs, it is essential to perform a final verification of the repair. Begin by clearing the stored DTCs from the PCM, which allows you to reset the system and monitor it for new issues. Next, perform various engine tests under typical driving conditions to ensure everything functions as expected. Running the engine at various RPM levels and checking sensor data can help confirm that the AF sensor and other components are working correctly. Finally, recheck the DTC status to ensure that the previous fault code does not reappear. This verification step is vital for ensuring that the repair was successful and that the sensor circuit is functioning optimally. To prevent future occurrences of DTC P0135 and ensure the longevity of the air-fuel ratio sensor and its connected systems, regular maintenance is crucial. Owners should consider making routine inspections of the AF sensor every few service intervals. It is also wise to check electrical connections regularly, looking for signs of wear, corrosion, or damage that might lead to malfunction later on. Performing routine diagnostics using either the Honda diagnostic system or an automotive scanner can help preemptively catch any potential issues before they escalate. Additionally, keeping the exhaust and intake systems clean from carbon deposits can maximize sensor lifespan and overall vehicle performance. In summary, understanding the role and function of the air-fuel ratio sensor, DTC P0135, is critical for effective diagnostics and repairs on the Honda CR-V 2023+. The troubleshooting steps outlined provide a systematic approach to identify and resolve issues stemming from the sensor's heater circuit. By following these steps, technicians can accurately pinpoint faults, ensuring optimal performance and emission standards are maintained. Additionally, prioritizing preventive maintenance strategies can extend the lifespan of the A/F sensor and related components. This proactive approach contributes to a more dependable and efficient vehicle operation, reducing the likelihood of future DTC occurrences and ensuring a smoother driving experience. Please like and subscribe to the channel. See you next time.